In this question, I am going to take two blocks, one over the other. Suppose this is 10 kg and this is 5 kg, and this two block system is on a smooth surface. So this is this surface, I mean 10 kg, and the table is smooth, while 5 there is a friction between 5 kg and 10 kg. Suppose it is friction, there is a friction and coefficient of friction is 0.4. I mean is static friction and kinetic friction coefficient, and their coefficient is 0.4. Now I'm exerting a force F on this system, and the question is, what is the maximum acceleration up to which both blocks moves together? To solve this problem, first we have to find the limiting friction between the two blocks. So normal force is 50 Newton, which is mg, actually 5g. So Fs max limiting friction, which equal to mu n 0.4 into 50, 20 Newton. So this 20 Newton is the limiting friction. Limiting means maximum static friction between these two blocks. Now if this force, I mean friction force, acts on the two blocks, it is the only friction the friction force is the only force that accelerates 5 kg block, while F is another one more force on 10 kg except friction that accelerate it. So if I make a block diagram, 5 kg and 10 kg, so there is a friction, static friction, and there is a force on 10 kg, there is a force, external force F, and static friction. There is two force on 10 kg and single force Fs on 5 kg. So the static friction is the only force on 5 kg that accelerate it, and this force accelerate, if this is suppose its acceleration is a, so we can write Fx equal to 5a. I mean if acceleration of 5 kg increases, the needed static friction also increases up to 20 Newton. So this equation can be written as Fs max equal to 5 A max. I mean the limiting friction is the maximum static friction which can accelerate 5 kg to its maximum value. So if this is 20 Newton and this is 5 A max, I mean A max equal to 4 meter per second square. So it means the upper block cannot accelerate more than 4 meter per second square, because it can be only accelerated by the friction force, and 10 kg can have as much acceleration as we can because of this force, external force. If keeps on increasing the external force, its acceleration will also increase, but 5 kg will be at the mercy of friction only. So it cannot have more than 4 meter per second 4 meter per second square acceleration, maximum acceleration it can have. So before acceleration reaches maximum value of 4 meter per second square, both blocks will move together. It means the two blocks will accelerate with the same acceleration up to this value. So we can write, so for a less than 4 meter per second square, both moves together, and we can 10 kg and 5 kg, we can take these two together as a one system because both have the same acceleration, and let it be A. So A equal to F upon 10 plus 5. So this equal to 15. Putting A equal to 4, F equal to 60 Newton. It means if the applied force is 60 or below 8, but both blocks move together, and above this they will separately accelerated. I mean they have different acceleration. So for F less than or equal to 60 Newton, both will move together, okay, and their acceleration will be F by 15. Let's have an example. Suppose F equal to 30 Newton. F have 30 Newton. It means this is below 60 and both have the same acceleration. So what can we do? We can find their acceleration. Acceleration of both block will be equal. A1 equal to A2, F by 15, and that equal to F is here 30 Newton. 30 upon 50, I mean 2 meter per second square. So both have same acceleration. Now for friction, as I've told you, the upper block is at the mercy of friction to accelerate it for its own acceleration. For upper block, its acceleration, I mean its acceleration is A1, this is A2, so acceleration is 2, you know, it is equal to Fs by its mass 5 kg, because I have written for upper block it is at the mercy of the friction equal to 5a. Now a is 2, so 10 Newton. So static friction between the two block is 10 Newton here, and acceleration is 2 meter per second square for both block. Now I'm going to take another case in which the external force is greater than 60 Newton. Suppose F equal to 90 Newton. I've told you at this force both block will move at different acceleration. Now this is 90 Newton above 60, so the both block will have different acceleration. Separate these two block a bit. I am lifting a bit to show they are separately, so it's separately. Now it is the friction. Now there's a slipping, so this kinetic friction, as mu s and mu k both are equal to mu, so Fk equal to F limiting friction, which was 20 Newton. So this has 20 Newton and there is a 90 Newton. I want to tell you that if this force, external force, is above 60 Newton, whatever be the value, this friction will be constant. I mean this 20 Newton will not exceed. So if this acceleration being constant, it has always same acceleration equal to this force 20 Newton, and this is 5 kg, so 20 by 5, I mean 4 meter per second square. It will have constant acceleration. Now according to Newton's third law, there is a reaction force of 20 Newton friction in opposite direction on 10 kg. So acceleration of 10 kg will be 90 Newton minus 20 Newton upon its mass. So 70 by 10, 7 meter per second square. If I write it as F, so A2 can be written as Fk upon its mass 10 kg, and A1 can be written as Fk by its mass, which equal to 4 meter per second square. So this is the acceleration of the two block if the force external force exceed 60 Newton. Here it is 90. Now here I'm going to make a graph of the acceleration versus force. So as I told you, if force F is less than or equal to 60 Newton, both will have same acceleration. A1 equal to A2 equal to F upon total mass of the two block, I mean 15. So this acceleration is directly proportional to force, and suppose it has like this. So A1 equal to A2, and this is up to 60 Newton. Now after 60 Newton they will have different acceleration, where upper block will have constant acceleration of 4 meter per second square whatsoever with the value of F. So its acceleration will be A1 will be equal to 4 meter per second square. So this is the maximum acceleration, 4 meter per second square. Now above this force, if F is there, the acceleration of the upper block will be equal to A2 equal to F minus 20 upon its mass 10 kg. So its acceleration will be a bit more, I mean like this. So this is A2. I've told you that this is external force F, this is 5 kg, this is 10 kg, and the force on this is 20 Newton when they have a different acceleration. So the net force on lower block will be F minus 20 upon 10 kg. So this is the acceleration a bit more than 4 meter per second square. So it keeps on increasing because the external force can also increases over the time. So this is the graph of acceleration versus force. This question is for you viewer. Just answer this question and send me its answer to the comment below. And the question is the same question that this is almost the same question that I have discussed. What maximum force that should be applied on 20 kg so that the both blocks move together? Second, what maximum acceleration 10 kg can have? And if this force be double of this maximum force up to which these blocks move together, if this force be double of this value, what would be the acceleration of the both blocks and the friction in that case? Please send me in the comment below answer. I will check if that's correct. I will connect you, I will reply to you. This is another case. This two block 5 kg and 10 kg, and the friction coefficient between 10 kg and table is 0. I mean this surface is smooth, while the friction coefficient between the two blocks is 0.4. Now instead of lower block, if I applied a force on upper block and discuss the same situation as earlier I have discussed. So here the external force acts on the upper block, and 10 kg will accelerate or move at the mercy of the frictional force between the two blocks. So first is I'm going to find the limiting friction between the two, which is normal force equal to 5g, I mean 50 Newton, and Fs max limiting friction, and which is also equal to kinetic friction, and both will be equal to mu n, I mean 0.4 into 50, this equal to 20 Newton. So the limiting friction between the two block is 20 Newton, and this will be also equal to kinetic friction once the block is slide over the other. So this 10 kg block will accelerate at the mercy of by the help of friction between the two block. I mean, this can be written like that, this can be made like that. This is a force F, and if this move forward and have a tendency to slide forward, the friction force on the lower will be in forward direction, that will accelerate it, and Newton third law, there is a reaction force on 5 kg will be in opposite direction. So if this friction, this is 10 kg, accelerate this, it suppose its acceleration is represented by a1 and its acceleration in a2, equation can be written for 10 kg, F equal to 10 a2. So increasing friction also increases its acceleration, and its maximum value is 20 Newton. So if this is 20 Newton, sorry, this is 10 a2, so maximum acceleration of the lower block will be 2 meter per second square. So by the friction, lower block cannot be accelerate more than 2 meter per second square by the help of friction. So if both block moves with this acceleration, they will move together. So if they move together, we can take as a single body, taking these two as our system. This can be written as 15a. So putting a2 equal to 2 here, maximum force equal to 15 into 2, 30 Newton. So this is the force, limiting force. If the force F exceed 30, they will be accelerated separately, and if this force is applied force is less than 50, they will move together, because lower block cannot have acceleration greater than this. So for moving together, the upper block must have acceleration below this value. So for below this value, the force must be below 30 or 30 Newton. So this is the boundary level above which they move separately, below this they move together. So let's take two cases for moving together and separately. Let's take the two cases. First is F equal to suppose 20 Newton and F equal to 50 Newton. 50, or let's take 45 Newton. So this being below 30 Newton, both block will move together. So we can take the two block as our system. The force is on upper block, and we can take this together. So acceleration will be 20 upon 15, I mean this equals to 4 by 3 meter per second square. And friction force, this is the force, this acceleration both block will have, a1 equal to a1 a2 equal to 4 by 3, and we know this lower block is accelerated by friction only. So friction between the two block will be 10a, I mean 10 into 4 by 3 means 40 by 3 Newton. Now if force is more than 30, this 45 is more than 30, so both block will accelerate separately, this being 45 Newton, and there is a limiting friction Fk which equals to 20 Newton. So it's there's another friction opposite to that, and that equal to a1, and it will have a2. So For A1, for upper block, it is F minus Fk upon its mass. M1, I mean 45 minus 20 upon 5 kg. So it acceleration will be equal to this equal to 25 upon 5 meter per second square. So increasing F definitely increases its acceleration, while the lower block will have a constant force of 20 Newton in the forward direction. So its acceleration will be equal to Fk upon its mass, I mean 20 upon 10 kg, which is equal to 2 meter per second square. Again, graph will be similar to that. Force, same acceleration up to, I mean 30 Newton. After that, one have constant acceleration, which is A2, and while that of the upper, it acceleration increases with the force. So this is the graph, and I'm going to give a question for the viewer also here. Now I have two blocks. Suppose this is 4 kg and there's a 3 kg and the force 30, suppose 21 Newton. This force acts on it, and this is a smooth, and suppose this is 0.2. So what will be the acceleration of the two blocks here, and what is the friction between the two blocks? Just send me answer and on the comment box. Thanks for watching. There is another case in which there is a friction force between all the surface in here, I mean between the two block and the block and surface. In the next video I will include this case. Till then, keep watching.